Hello everybody, I'm in the Cranias lab in Cincinnati and next to me is Dr. Kobra Haghighi and she's going to take us through the lab. And Kobra, what are we looking at this place?
Right now we are looking at a complex called Langendorf system, and here we hang the heart basically, and then we can do some functional studies and give some treatment to see how the function changes. And from there we can analyze the whole data on that computer there, and we can see actually the heart rhythm and function, contractility, and all whatever we need that to analyze and tell us how the function of the heart is functioning.
Wow!
So that's what we do. And over back the other side we have that apparatus. Actually, we isolate the heart in this small unit right there, and when we hang there, then we can again isolate actually to single cells the heart, and take the single cells called cardiomyocytes, and then again look at function at different levels and look at the contractility of the how the contract relax the cells, and that tells us a lot about how the whole heart will function in the body. So, and from there on, we can also do some look at the heart rhythm, and by doing the like ECG, echocardiography, not electrocardiography. Sorry, you're right. And then we can basically, as you can see, we can look at the heart rhythm again, and is the heart beat is fine, or is there any irregularity, and then we can compare that one to a healthy heart, and in that sense we can see how the heart again does in the whole body. And sometimes we can get that heart after the we check the rhythm and do extra analysis for protein levels and biochemical levels, and that also gives a lot of information how the heart worked on the stress condition, not just normal condition. We stress the heart, adding caffeine and also a compound called epinephrine, which is like stress. It's like the isoprenol.
Sort of adrenaline.
Exactly.
Yes.
And that's also that shows us how the heart, the mutant heart that we have, acts under stress condition, and that tells a lot to us too, which relates to the patient's phenotype.
Yeah,
as
because
well.
you've got mouse here who have the
Yes.
same deletion as
Exactly.
the people have.
Exactly. These are the mouse that have the same mutation and the same deletion that in the patients, and that's what we can compare and see how close phenotype we get, and what is the mechanism, and how can we figure out to tease and figure out if we can fix it.
Yeah. And what's more in the lab?
And then, as you can see, we have a lot of instruments and things around that we use. This is like a centrifuge at a cold system, and we use this one when we isolate protein and things like that. And then it keeps the protein integrity; it doesn't get degraded. So then we can, when we analyze it, we can actually have the intact protein, the phospholamine that we know have the mutation. That's one of them that we try to isolate from the whole heart or the myocyte cardiac cells, small single cells, and then follow through and do lots of analysis that we need to do at molecular level. So there are a lot of instruments we use. This would be the Western bench that we use actually right there. There's a gel they're running, and that gel is we stained them recently, and we sent to the different place to analyze the whole protein and what proteins are interacting with each other, and that helps us again to figure out how we can pinpoint where we can find a place that we can correct or do some manipulation and help the heart function.
Yes.
So beside that, we have another student here who is busy, so you can say hi.
Hi. How are you?
He's busy.
Yes, I,
Hi.
yes, I met you before.
Yes.
Yes, I met you before.
Good to meet you.
Yes,
Yes.
He's one of the
Yes,
students,
nice to meet
PhD
you.
student,
Yes,
PhD student, and he'll have a different project working on, which is also related to calcium cycling. He's actually genetics. He worked on genetics as well.
Yeah.
So do a lot of sequencing.
Like
He has a lot of experience.
Two mutations with this phenotype of hypertrophic cardiomyopathy and DRSMA also.
Right. That's
Yeah.
what he's working on.
It's nice to
Okay.
meet you.
Thank you.
Nice to meet you.
And then we can walk around, and again you can see that different areas have different apparatus we use. And then we can see one of the students who's actually doing an exciting thing, working at the at the sarcomeric protein. And here is Mohit, who's going to tell us what he's doing with
Hello,
mutation.
Mohit.
What do you do, Mohit?
So I'm trying to link the gap between how the mutation in sarcomere can affect the whole calcium handling,
Uh-huh.
and that way we can know how sarcomere mutation can cause arrhythmias, and if we can treat sarcomere, can we prevent the arrhythmias also? That's
Okay.
Now
Thank
you
you
are
very
doing
much.
the calcium sensitivity of the
yes, yeah.
the
So all
phospholamban
so
mutation.
So yeah, with the phospholamban, we're figuring how the mutation phospholamban can affect the calcium sensitivity itself, the reverse way, how the calcium handling protein, the phospholamban, can affect the sarcomere function itself.
Yeah.
So it's a both way direction.
Thank you.